And we're live. Okay, I just wanted to quickly go over the clipper that is approaching the region with a couple of observations that I wanted to point out here. So I'm glad everyone could join me on YouTube and Twitter. So let's get right to it. Right now, when we look at our surface observations, we're in the 40s and 50s. This is an important factor because it gives us a better idea. Let me move the mic closer, of course. That'd be a smart thing to do. It gives us a better idea on the evolution of the boundary layer and what will need to be lifted in order to overcome these warm temperatures. And I'm not just talking about warm temperatures now. Obviously, this is going to be occurring around midnight, so this really wouldn't matter. But the additional heat is being absorbed into the roadways, into your cement, into pavement. And so that has an impact on how much is actually going to accumulate on your roadways, your sidewalks, versus cold surfaces like the grass and your car tops, for example. So the area that we're going to be watching is right here. This feature right here, as this clipper quickly dives towards the coast, is going to be diving towards our neck of the woods. The heavier precipitation here is what's key. Where this tracks, that's where the heavier snow and rapid cooling will take place. So the faster the rising air occurs, the more cooling we could see, and therefore the better potential for snowfall accumulation. And when we take a look at the 850 millibar anomalies here, and you see the gradient here setting up, pretty impressive thermal gradient that is in place over the region. Let's refresh this and get a better view here. Zoom in, and you can see the thermal gradient and the strong warm air transport. So this frontogenesis right here is what's going to be the key factor here in determining just where that intense band sets up. So as this 850 millibar low transfers, not even really tracks, but transfers towards the coast, that's where we're going to get the heavier burst. Now, why does the snowfall look like it's weakening as it dives towards the coast? Well, this signature right here, and it shows up also really nicely here on the upper level winds using Earth New School. You see how this kind of converges here? This leads to convergence and confluence aloft, which is a weakening factor. That's why when this clipper is diving towards the coast, it intensifies in this brief period of divergence and diffluence, very short window, and then it falls under this area of confluence, closing the window down. So the window's open and then gets slammed down. And so when it gets slammed down like that, it crushes the system. So that is why when we take a look at the model guidance here, and let's use the HRR guidance, you can use the NAM as well, but it's showing basically the same idea. This comes in, blows up under that area of divergence, and then it runs into that window. And notice that the precipitation starts to get much lighter. And also notice how fast this is moving. So this is a fast-moving system with a short window of intensification, then suppression, falling towards the coastal plain, where we already have a very warm boundary layer already in place, making accumulation a little bit more difficult. So based on that, the going forecast right now is the heaviest snowfall, or the best potential for snow accumulation, is going to be to the west of Allentown. Why? These locations are, one, starting off colder, two, are going to be an area where the divergence and diffluence, upper level lifting, is going to be strongest, and three is going to be where it's going to occur around midnight. So optimal periods of snow accumulation during this time period. You're only talking about 2-3 hours max of heavy bursts of snow, and then it's done. So for those who are looking for 6+ inches of snow, 8-9 inches in some of the model guides, understand that you're going to have to produce snowfall ratios or a snowfall rate of over 3 inches per hour. Is it possible? Sure, this is meteorology. Anything's possible, especially if you get just enough convective precipitation and you get this feature here remaining in place. It is possible, but unlikely. And then as you head down towards the coast, with the system steadily weakening and a warmer boundary layer to overcome, overall, that's where you get less snowfall. And so we got 1 to 3 inches from Allentown to Trenton, just touching New York City, right around Newark. And then for central New Jersey, talking about Philadelphia, Trenton, Monmouth County, looking at anywhere between a trace to an inch of snow, mostly on your cold surfaces. If you look at your roadways, they are warm right now, and they're taking in a lot of this sunshine that's going on right behind me. So that's going to be a limiting factor, in my opinion, as this storm rapidly dives through. We'll be keeping an eye on the observations and keeping an eye on the latest model guidance as it comes in, and we'll update accordingly. In the meantime, stay safe out there.